report. Okay. This one's about encryption. So, of course, that's what happens when I click on something other than that. Let's go over here, click again. This is where we'll get this working. This one has a lot of different concepts, but it's a fairly quickish lab. The goal is we're going to go over SSL and how everything works. So if you guys remember, in most of our web services, we use port 80. That's HTTP. Here in later years, and most of the years, most of you are in this program, everything is pretty much running on HTTPS these days, especially with the advent of getting free certificates and everything else when it used to cost lots and lots of money. Still does cost lots of money, but if you use Let's Encrypt and some other cool services, you can get those for free. Those SSL and TLS are secure network communications. It allows for us to encrypt for data privacy, using hashes for data integrity, and uses our certificates for authentication. So on the outside world, this means, we have it on our inside zone, we have it on our outside zone. Our Palo Alto is going to do what we know as a man-in-the-middle attack, so to speak, where we are going to take the certificate that comes from the internet, we're going to sign it as ourselves, and then ship it down to the client user on the inside. So we're going to inspect that traffic and replace it with our own certification that we say is valid, right? So I'm good, send everything, we're going to let it happen. That decryption allows us to help prevent any kind of malware introduction or data exfiltration. So right now, we have to allow SSL traffic, or we have no traffic anymore, right? But if a hacker or somebody was on the inside of our network, all they have to do is ship it as HTTPS back across the connection, or SSL in this case, and all of a sudden our Palo Alto can't see it, right? So that's why we set up the decrypt and inspect side, is so that we can go back to making sure that's not happening. Most of our web traffic, like I said, is now encrypted. We can decrypt both SSL inbound and outbound traffic, as well as SSH version 2 traffic, right? So most of this is going to use digital certificates to validate the identity, in which case our client requests an SSL connection, for example, to a web server. The web server sends us a server certificate, which is a signed copy of the public key. We then verify that server certificate. We do that by consulting the root certificates that are built into the machine as to who actually authenticated that certificate. We will then send an encrypted copy of our session key up to the SSL server. That server will then use the private key to decrypt all the copy of the traffic that is sent to it by the client, and then begin using symmetric encryption for that traffic going back and forth. There's a couple different decryption types we can do on a Palo Alto. The first one is forward proxy outbound, in which case we basically just set as an SSL proxy in the middle. We can do SSL inbound inspection, where we're just doing the inbound side of things, not the outbound. Or we can do full SSH decryption down at the bottom, in which case we are acting like an SSH proxy, all right? So usually the first one at the top is the most common. If we want to intercept any SSH traffic, we can do the bottom one. The middle one isn't as common because we don't really have a proxy coming in on the outbound, but on the inbound it is working. Okay. So public key infrastructure, most of you should have at least been introduced to this along the way so far. So as a recap, it solves the problem of secure identification of our public keys. It uses digital certificates to verify those owners. And the typical component goes to our root certificate authority, which carries a database of certificates. They certify the intermediate CAs, or certificate authorities, with their database, and they issue certificates out to devices or a certificate store, right? This is where your trusted CA, certificates, private keys, and everything else is held on the device. So root authorities are generally your top tier level issuers that are going out there. DigiSign, some of those other ones, those are usually your top tier side. You will have ones like, say, Namecheap or GoDaddy, right? Some of them are now roots, but they usually are intermediaries that are in between there. So they are verified by the root directories on the outside, right? And therefore you can sell cheaper certificates. This would be your chain of trust. So the root CA is going to do all the validation over there on the left-hand side. which will issue a certificate out to the intermediaries who then issue out to the devices themselves. And then you can trust going back the other direction. This is essentially what happens with Let's Encrypt. It's just that that certificate is only valid for 30 days, right? Or 90 days, depending on how you use the API. Most other certificates are 1 year up to 3 year. So if you use like Komodo SSL, which issues full-blown certificates or wildcard certificates, you're generally going to get 1 to 3 years, and they can cost you several $100s to several $1,000s, depending on the level of what certificate you're looking for. All right. In here, you can get your certificates. So in device, certificate management, certificates, these are the different operations you can do and things that you may need to do for your system. So you can generate your own certificates. You can view certificates or modify them. You will import or export certificates, which is generally what you would do in most systems. Delete certificates or renew and revoke certificates. The most of the time when you're doing generating certificates, that's when you're creating your own for VPN access. So it's built by the firewall. The firewall issues a certificate out to the devices for the clients to use to authenticate for global VPN, right? Otherwise, if you're actually trying to authenticate the main system, it's probably going to be an import or export from an outside party. I will tell you, certificates are the bane of existence for most Palo Alto administrators, right? They're a necessary evil. When one of these expires because you forget to go in and check, services stop working, right? 9 times out of 10, when something stops working, when I'm out in the field with the customer, it's because a certificate expired and somehow it wasn't on our list knowing that it was going to expire. And other times you know it's going to expire and then 60 days go by and you realize you forgot to update the certificate again. It happens. So this is usually the number one place I check. If something's going wonky on a Palo Alto, let's go check our certificates and make sure everything's valid. It's really simple because when you get into this management system, you can go in and look at status, make sure everything's greenlit, right? The API is really easy to work with. I built a real simple Django application that you guys would use in like advanced Python class. It interacts with the XML. It can pull all those out and just gives you green light, red light all the way down, right? Super simple. There again, great use of being able to use the XML API. It's very simple to use. You can see all those here. So for example, this one's going to have the firewall certificate authority cert, and then that one is going to issue the individual certs that are down below it. So you have ones like Forward Trust, Global Protect Portal, Global Protect Gateway, and then maybe a Web UI cert that you issue off of there. You could also do individual device certs if you wanted to give clients their own cert. For example, this is J Zeller cert, and I can issue that out, and they have to use that to connect to the global VPN for my individual user account. OpenVPN is another good way that they issue the same way, certificate-based. So this nested hierarchy, as you see over there, it kind of tiers. That helps illustrate the chain of trust for that particular certificate. So all those other ones I mentioned are going to be under the original certificate authority one at the top. Now, you can issue your own certificates with OpenSSL if you want to. So if you guys have ever done that via the command line, you can generate your certificate authority one, and then you can issue a bunch of individual ones out. That can be useful if you have to connect, like, say, multiple firewalls, right? They're all kind of their own certificate. You want them to be the same across all of them. You will then use import export to get those in there. Another place I've done that is on, what was that for? Active Directory and Synology. When we talked about using Active Directory as a way for our users to connect, we would issue them through OpenVPN because we could set the time to like 3,000 days. So I basically gave it 3,650 days, so 10 years. So I don't have to worry about that stupid thing. It's not exactly secure, but it's an internal certificate. It's really not meant to go out to the internet. It's just on the inside. We issue those on 10 years, and then you can take that from a OpenVPN server or, OpenSense firewall. I just use it as a GUI for the certificate side, and then we issue all the certificates out from there. You can dump them into your Palo Alto, but you can generate them over here. You just export the keys out and match all of your Palo Altos together. All right, certificate creation. This is really what I was just talking about. So if you're doing self-signed certificates, you generate a certificate which has both the public and private keys for the firewall. Then if you have a certificate, authority signed certificate, you create a certificate. You sometimes will import that certificate in from a certificate authority, or you could generate a CSR, which is a certificate signing request, and the public and private keys. You export that CSR file, send that up to a certificate authority, in which case they will sign it and return the certificate in file format, and then you import that into the firewall there as well. All right. So this could all happen at the certificate authority, or you could have the firewall generate the certificate request along with the keys and everything else locally, and then ship that up to the CA so that they can sign it. Adding certificates is really easy. You go into the certificates, hit add, you give it a name that's just for local reference, the common name, whatever you want to send there. And then the signed by is who you will typically leave blank if you want it to be a self-sign. If you're using a certificate authority like Namecheap, et cetera, they're all in the drop-down. You can pick that. Then you can mark whether this is a certificate authority certificate, or if it's not, it would just be a user one. You can adjust all the cryptographic settings here. So for example, RSA 2048, you can bump that up. The digest is usually SHA-256. You may want it to be 512. And then your expiration date, they have 365 if you want a year-long one. Palo Alto, I think, caps it at 365. I don't think you can go longer than a year. I could be wrong, but I think the last one I did didn't. And that's the reason I used a third-party thing to create the certificate and then just imported it into the system. All right. Here's how you import that. Okay, use an internal certificate. The certificate authority one you get from them, you import it in, just like I do here. Most of these will come in as a PIM file, which is just a base 64 encoded version of the certificate. If you get it from the vendor as a text file, then you just need to take that text file and save it as a .pim. And sometimes it'll have a chain of different ones. So for example, GoDaddy is one where you have to like copy the main certificate, you have to grab your intermediary ones, and then it will sign it with the root one as well. And you just copy that all into one text file and save it. Sometimes you'll get it as a PIM, sometimes you'll get it as a CRT file. You just have to pick the right file format so it matches up. And then you can either import the private key or not, depending on what you need. This will be your key file on that side. So you'll have a cert file and a key file. And then sometimes those are set up with a passphrase so that you have to enter in a passphrase to decode the file and actually bring it in. Right? All depends on how this was generated by whoever your certificate authority was. That CSR, or your certificate signing request, this is again where the applicant creates a public private key pair. The applicant will then sign it, encrypt it with its own identity information using the private key. That applicant will then send it off to get signed by a public key at a certificate authority. They return the actual signed certificate. The advantage of that is the device is now part of the PKI, which is the public key infrastructure, and is a benefactor of the chain of trust. The private key never leaves the device, right? If you generate it at the CA, they are generating the key that you would ultimately use on your device. If the certificate authority was ever compromised, somebody could get access to that private key, right? And we all know how, people are uber secure with this kind of stuff. Certificate authorities, probably. However, your social security and credit card numbers, maybe. Same concept. Somebody gets in, they could get access. Imagine getting access to a root authority's list of private keys for all the certificates they ever signed. Be like really, really bad. Okay. Generating a certificate authority for a CA signed certificate, same concept. This is how you do it. You go in, you hit add. Instead of the signed by, you'll choose external signing authority. Leave those other ones blank so that it's going to create it empty. And then you can export that and bring that into a certificate authority to bring that back. All right. Usually it's going to be this PIM or SIR file with base 64 encoding. If it doesn't come that way, then you have to translate it to be base64 encoded, and then you can export the certificate, which is usually a CSR file format. All right, so how does that check that it's actually valid? Well, we'll determine the certificate chain of trust. Is it valid? Each certificate in the chain, signature valid, date range valid, is it malform or corrupt? Check the revocation status of each certificate, and that can be done using the Online Certificate Status Protocol, or OCSP, or it could be on the certificate revocation list of a CRL. All right. Reasons why we would revoke those is the private key ended up getting compromised, a host name or something changed, the host is decommissioned, aka a user left the company, or a counterfeit key was found, and other statuses that could come back as current, expired, unknown, or unavailable. All right. So a lot of times if we send one out and we found out somehow that got leaked on the internet or somebody got our private key, we have to go in and revoke that off all of our systems, and we send it out to the certificate authority to get put on the certificate revocation list, so that if it goes out on the internet and people are still pulling the old one, it knows to clear that certificate out. We've had to do this when I was in industry at least once. We had a web server that got compromised and the certificate private key got leaked out, and so we had to remove it, create a new one. It is a nightmare because it takes forever to get through the process to update all the certificate authorities. During that time, your users can't go to your website, right? If you're HTTPS only, there's no way for them to get to the website without getting the alert saying this certificate is not valid. We've all seen websites where people forgot to update their certificate, right? I don't care if it's Walmart. I've seen big name websites that, whatever reason, didn't update their certificate. Even Fort Hayes, you may have seen our Fort Hayes website. That certificate didn't get renewed automatically like it was supposed to. All right. So when we configure that SSL decryption certificate, we have to have two of those. We go in here to the certificate revocation checking status, and we make sure both of those are enabled. You can do either or, depending on what protocol you want to use to check it on. Now we're going to do decryption. So the way that works with an SSL forward proxy is on the left-hand side, you have the client, right? They are going to verify that that certificate's valid, but we are doing that at the point of the firewall. So the firewall grabs the original certificate and everything from the SSL server, sends it here. We are going to have a valid certificate that is between us as the firewall and the end client, meaning we have to push this certificate out to every single one of our clients that says we are a root authority, all right? So it's a little bit more of a cumbersome setup, but this establishes communication between us and the firewall. This establishes communication with the real world on out. We do that so that we can decrypt the traffic here, read it, inspect it, then send it back out and actually encrypt it with the firewall who has the real certificate on the outside. All right. So it looks something like this. An internal user will forward a trust certificate, request an SSL connection. The firewall will then forward that untrust certificate off to the external server, which has the server certificate, and then it will send that on back down the direction. Okay. The firewall then sign a copy of the server certificate with its own forward trust certificate if the certificate is trusted. If it's untrusted, the firewall just signs a copy of the certificate with its own forward untrust certificate. So you have to have a trust and an untrust. Here's how you configure that. So you go into your certificates, you create two different certificates, the untrusted and trusted. Those must be valid certificate authority ones, aka created here by the firewall. And we must set them up as forward trust certificates over here on the right. So you would pick the appropriate type of authority over here. All right. Same concept over here. This is where you can set new expirations if they expire. It's pretty easy. If a firewall certificate and it was issued by the firewall, all you have to do is come in here, set the new expiration date, hit OK, it blasts it out. All right. Now, the ones that are living on the actual clients, you would have to blast that out to all the clients to set them up. All right. Usually that's done with whatever management software you're using for that operating system. So if it's Microsoft, for example, you would use that as part of your Microsoft ADN. When it signed in the next time, it would be told to go pull that new certificate and inject it into the registry. Policies for decryption, we set that up under policies, decryption, we set up a new rule. You have general source destination. It looks a lot like a general security rule. Only on the decryption side, we're going to grab what services we're listening to. This would be typically service HTTPS, but we may have SSL traffic on non-standard ports, in which case we have one created over there for 62443. Let's see, decryption, subject, legal, yeah, etc. And then down here at the bottom is where we will actually tell it to decrypt that one. And then we can say which type of policy we're going to use for our decryption, and then what profile, decryption profile, we're going to use to match that up. That decryption profile is over on the left-hand side. So for us, we're going to use this SSL forward proxy. We can block search sessions that have expired certificates, et cetera, untrusted. So we can keep people from going out to the internet and going to those websites that say not a trusted certificate and block that, right? We may want that for the internet, but can anybody think of where that may cause us problems on our own network?
Internal, anything.
You got it. So say you have a Proxmox server running on the inside, right? If it's signed by itself and it's just an internal self-signed certificate, this would actually block traffic going to that, right? So you have to be a little careful there. It would make sense to then go ahead and generate a device certificate from the Palo Alto and send it off to that device to where it's actually properly named for whatever it is. All right. Policies decryption up there in the upper right. This is where you're going to attach the correct profile. And then that profile in the lower right is where you can specify which protocol versions you will support, including the min version and the max version in there. Okay. This will now have new support for TLS version 1.3. And you can determine which key exchanges you want to set up. A lot of that is dictated by the certificates that you're getting further up the chain, right? Depending on which you're going to be decrypting. On the inbound inspection review, this is very similar to the other side, only we're just doing it in one direction. All right. So the client itself is going to send an SSL request over to the server. The server is going to send that back to the client. We'll establish that SSL encryption, but we're going to actually bring that certificate over here into the firewall itself and import that in from the outside world. All right. The only negative to that is obviously if it expires, then we have to manually go and pull that certificate back into the system. So for example, if we go out to Microsoft.com, we download that certificate, upload it into our firewall, we can go ahead and sign it back and forth. However, if Microsoft one expires, we have to go back out to Microsoft and grab the new one and install it into our firewall. All right. The other method, we bypass all of that because we only send and receive our own certificate going out. I went the wrong direction here. There we go. All right. Let's see here. This is when we're going to be doing our internal server certificate, and the private key looks exactly the same as we did before, and you can set up the import of it there. SSL inbound inspection policy. Again, you can set up the two certificates of what's going to be in there and what we're blocking. If we're setting up multiple of these for that particular type, we have to choose multiple certificates that we're actually allowing to go through there. This one, when we create this SSL inspection program, notice that on the block section here, we can only block certain things. So it's either supported versions or sessions with unsupported versions or unsupported cipher suites. We can choose to block those two. We don't have the options to block invalid certificates and all the other stuff because they have direct communication out to that server. All we're doing is going manually pulling out those certificates and putting it in so we can decrypt that traffic in between. Decryption exclusions, we can come in here and we can set specific locations where we do not want to decrypt those particular things. So for example, if we're going out to service.paloaltonetworks.com, we're not going to actually inspect that traffic, right? This is handy where you set up those wildcards over there on the left-hand side so that we just don't inspect any of that kind of traffic going through there. And there may be reasons we don't want to do that. Like It's a known trusted authority on the outside, and we are uploading HR records or something like that. We don't want the firewall to have copies of that decrypted along the way. It could also be done in a government level setting where they don't want you inspecting this particular traffic. And so you have to set up those exceptions in there. All right. Even if the decryption policy is set to no decrypt, the decryption profile can still be configured to block sessions with either expired or untrusted certificates. And we saw that option here where we could block that over here in the middle. Let's see, decryption troubleshooting. This is in the logs where you can go in and look at the decryption section and see traffic that was actually being decrypted between the two. You can also go and look in the ACC side and look at our SSL activity. Most of the time when I go look at my firewall, it looks like this, right? Everything's encrypted these days. So unless I'm running SSL decryption, there's no way for me to block that going out there. All right, let's see. Troubleshooting those sessions. You can go into your logs and traffic. We'll look for that session end. You may want to set up some filters in there that would be something like session end reason that there was a decryption error. And that would just kill the traffic. It wouldn't allow the traffic to pass. But if we could find those, we could correlate as to what's going on with that traffic. Anybody have any question on the SSL side of the thing? Right? So this is mostly us doing web traffic going across the net. We want to inspect that type of traffic and make sure that we can still have our antivirus checks, our malware checks, all of that kind of stuff going on. Making sure that they're going to websites that we only authorize. All of that has to be done through the decryption side. Now, SSH decryption, this is literally, terminal services basically writing across our firewall. We could decrypt that traffic as well, in which case it would decrypt and inspect any SSH version 2 traffic for tunneling purposes, right? So a lot of time as a hacker, and we show this in some of the advanced courses in the master's program, you will actually go infiltrate a network and then you will set up an SSH tunnel back to your head-in location or whatever else, and that will automatically renew itself every time it comes online. That way we have an encrypted amount of traffic going back to us. We now have it's almost like a VPN tunnel without a VPN. It's just an SSH tunnel. That allows us to get into a remote machine with all traffic being encrypted. If there's no inspection happening in the middle, I can pull all the information out of your system that I want all day long. It's going to hit in the firewall, think it's SSH or SSL traffic, and pass on through. A Palo Alto will actually inspect that to make sure that that's valid traffic. All right. So a user will do a request to the SSH proxy. The proxy will then send that request, aka a new request, out to the server. That will come back as a response from the server, and then we will send our own response back to from the firewall. And inside here, in that traffic and security policy, we add rules to control that SSH and SSH tunnel traffic. So we can see that we either set up bad SSH traffic, block any SSH tunnels. We could also have good SSH traffic, in which you'll notice this one is set to allow. So we deny the first two and allow things that are on the bottom. In this case, anything bad SSH traffic would be a source address of the 165.35 that it's showing here. However, we block anything that matches an application of an SSH tunnel. Most of the time, you should not have SSH tunnels running on your network, right? Unless you're doing something specifically for that. If you do, it's a good indicator that you're probably compromised in some case, unless you have a very specific application use. Okay, reasons why you would not want to configure SSL decryption. One, it's when your local laws or company policy prohibit us decrypting the traffic going across. When a server requires a client certificate where we have to forward that proxy in, a new certificate authority cannot be added to the client. A client software requires specific server certificates. Back to that new CA cannot be added to the client. Can anybody think of where that might happen? Think really small devices. your smart lights, smart light bulb, anything like that, right? Believe it or not, inside that light bulb is a little processor, and in that processor storage is the root certificate authority if they're sending back SSH traffic across the net. They have to have those root certificate authorities and how that works, otherwise they can't pass traffic, right? Well, it would be very difficult for us to probably update the root certificate authorities on a light bulb unless we actually set up the firmware and push out a new certificate, that kind of stuff to it. We probably don't have that option, right? In which case we would be blocking all traffic outbound. Now, is that a bad thing? Like, why should our light bulb be phoning home to whatever XYZ company over SSL? Probably shady in that regard. But it happens all the time, right? You buy this stuff on Amazon, everybody else comes in, you don't realize that that thing is actually phoning home the entire time. A great example of this would be Hikvision security cameras, right? Those things are constantly phoning home to China. You go out, buy one, it's a legit camera, but that doesn't mean that that camera is doing legit things 100% of the time. It's constantly trying to phone back home for some unknown reason, and you don't know why. So you want to set up that SSL inspection. In this case, you may not be able to push a new root certificate because remember, we have to tell that device that the firewall is a certificate authority. If we can't do that, then we can't use our little certificate in between, in which case we just have to block all traffic from that camera going outbound. Now, there may be a legitimate purpose for that. A good example is printers sometimes need to communicate back to a head-in somewhere so that they maintain service logs and records or something like that. That would be a legitimate use, but it could be a pain. Other ones that I've had actual students come back and tell me on is medical equipment in the medical field. It seems like everything this day, whether it's a pacemaker or not a pacemaker, a heart rate monitor, the kind of stuff you get hooked up to when you go to the doctor, it may need to phone back home for some reason. Most of our guys come back and say, that's not happening. And they get mad because they can't, some vendor can't get XYZ communication back to them. Why should that data be exfiltrated off their network, right? There's questions, and that you run into this with not just healthcare. We ran into it at the ISP level with a bunch of different devices. We were getting ready to buy a bunch of modems back in the day. Those things were constantly phoning home for no reason, not to us, but to the actual vendor. It wasn't like we agreed that they would get usage statistics or that kind of stuff. They just did it back in the day. These days, they, in theory, have to make you click a checkbox to do that kind of stuff, right? So if we can't update that certificate authority on that end device, we can't block, or we can't decrypt the traffic, which means we can't authorize that traffic to go through. We just have to block it. If the client software requires specific server certificates, we cannot inspect that particular section, or any non-standard SSL implementation is being used, all right? If they're doing their own custom SSL encryption, this could cause some issues going through there. Decryption port mirroring. This will allow us to export decrypted flows out of a dedicated interface on the firewall. Use cases for this include any kind of data loss prevention or network forensics. It does require a free license you can get. You set up your SSL client, it sends encrypted traffic out to the firewall. The firewall sends that plain text packet capture out to some device to capture that traffic. Right. The rest of it continues on out to the SSL server. This would be very similar if you guys remember when we talked about setting up the firewall as kind of just a passive listening device. Same concept, only now we're decrypting all the traffic coming through it. Also, this could be so that you don't put the load on the firewall itself for having to process this data. We could ship this off to a SIEM or something like that, where we could decrypt that packet information, not decrypt, but dissect that information into something useful on our side. Let's see, network packet broker. Oh, this replaced the decryption broker. Okay, so filter traffic is then forwarded down the chain and identifies. This is not something I've had to use in real life. I don't think I've ever deployed this side of it, so I can't speak to when you would use it. But it's a feature, and it's available for a cost, I'm sure. Hardware security modules. This is all new stuff because we never used to have this kind of stuff. So physical device is designed to safeguard digital keys. It will generate, store, and manage digital keys. It's used by the firewall for SSL forward proxy, inspection, master key storage, private key storage. All of that kind of stuff gets stored off on these little modules. A lot like your little USB dongle you guys can get for hardware security. Same concept on a Palo Alto. All right. A lot of information. This used to be a much bigger chunk of the course, and there should be a lab associated with this where you guys will actually do it. I encourage you to go through and do that going through here. Because it is really tricky to set up. There's a lot of moving parts to setting up SSL decryption. I haven't really had to do SSH decryption in real life, but there's obviously a use case for that and making sure SSL tunnels are not going across. In the environment and the customer I deal with, they have to have that. That's actually part of their product, in which case we obviously wouldn't decrypt that kind of traffic going through. The SSL one is actually one that we do for you guys doing the labs. If you guys were actually paying for the service on the cloud-based service, there we obviously decrypt your SSL traffic to make sure you're not using our virtual machines inside the pod to go do nefarious things, right? Don't go hacking inside the pod because it has internet access, right? So we want to make sure that you're not just packaging a bunch of SSL traffic and using our lab service to go do things you shouldn't be doing on the net.
Wish you just said something last week.
Well, okay. So the one here at Fort Hayes, I will proudly say or passionately say, I do not have that set up here. If you are doing that, I do have a way of logging it. It's not robust. That does not mean go break the system. Please don't break the system. It will be after the first of the next semester because I'll actually get something back in place. When I had a Palo Alto running the NetLab system, like actually the firewall for everything, I absolutely had this set up. Right now I have an OpenSense in the middle and it doesn't quite do it as good as a Palo Alto would have done it. Question time. It's our favorite time, right? You guys tired of taking quizzes and questions yet?
Yeah.
You ready for just summer? You can just do whatever you want. I wish I could do that. All right. Which two types of activities does SSL, TLS, decryption by the firewall help to block? Malware introduction, denial of service attacks, sensitive data exfiltration, or protocol-based attacks?
Like
There was two of them it did list in here. However, it did not use that word.
A and C. I don't
A and C?
make sense.
Yes, that's correct.
Yeah, A and C is actually what they said, but I'm fairly certain it did not use the word malware introduction. I think it was malware intrusion. But yes, those are the two that it talked about. True or false, CRL is consulted first if the OSP and the CRL are configured on the firewall. Anybody remember the order?
CRL or OCSP?
Yeah, if both protocols are configured for confirmation that the certificate is valid or whatever, if both are configured, which one gets consulted first?
I think it's the other way.
Yeah.
What's up?
You know,
OSCP.
OCSP is, I think, consulted first. So it's false.
Anybody have any idea that they're correct? They're correct. But,
Right.
okay. Yes. The idea is that you should be using the protocol first. The certificate revocation list is like a last resort. Okay. Which type of firewall decryption requires the administrator to import a server certificate and a private key into the firewall? Is that SSH decryption, SSH tunnel decryption, SSL forward proxy, or SSL inbound inspection decryption?
Or forward proxy.
Anybody have any arguments?
But they're probably right.
You're going to let the industry guys just kind of run that one?
They know what to
Good
talk
choice.
about.
Good choice. Yes, that is correct. True or false, the SSL forward untrust certificate should not be trusted by the client, but should still be a certificate authority certificate.
True.
It's true.
The point of having an untrust and a trust.
Yeah,
certificate at the
what
same-
would happen if it is not a certificate authority certificate?
Kill the traffic altogether.
Yeah, the device isn't going to use it for looking up to even trust that it's not trusted.
Yeah.
True or false, the firewall can check for expired or untrusted certificates even if the SSL traffic is not decrypted.
True.
Dun, dun, dun.
It's true, right? True.
Didn't sound like a confident true.
Your waiting says that
true.
feels like it's more true, but I feel like it's true.
true. All right.
I believe.
Yay!
It's true.
It's true.
And everybody remember that you have those check boxes that you can poke to have it check that, right? So true, true. Make sure the rest of you were correct, but I believe you were. DBAC, D, inspection. That's what you guys said, right?
I said forward proxy.
See, you can't trust those industry guys.
Which one was it?
This one here.
Oh. What's the difference between the two?
That's a great question. What is the difference between these two?
I asked. I don't know.
Well, that's the question is on this inbound inspection, what's the key word up above here that would make it that one?
Import?
Not necessarily.
Private key?
Or like this side might be the reason as to why, right? But the key there is this is you would import it, right? So does everybody remember the difference between these two? On the inbound inspection, that forces me to go out here to the certificate and go grab the certificate and download it, right? So this one was issued by Amazon as its certificate authority. Details I could see here all the way up to the root. I would have to download this certificate and import it into the firewall for it to work, right? The other one, which was our forward proxy decryption, that one we could either do it via import, we can generate our own, we can do CSR in order to get it in. We have lots of options. But in this last one, it's required that we actually import the foreign certificate and private key in order to decrypt. Otherwise, we wouldn't be able to decrypt if we don't have that private key. Make sense?
Yeah.
I encourage you to go through the PowerPoint again. I encourage you to go through this week's section, the materials, because this is fairly dense and a lot of you haven't played with certificates at this level, right? Some of you may have used Let's Encrypt or whatever service you use Let's Encrypt in the background and it just worked. This is something that is usually tricky for students to wrap their mind around and how it all works, right? Man in the middle attacks, does anybody know how that works on a network? Or what's another word for a man in the middle attack or a portion of a man in the middle attack?
Is it similar to DDoS at all or no?
They impersonate like a proxy, right?
Closer to that. So it's usually done via ARP poisoning. All right. Does anybody remember what ARP is for?
Yep.
Address resolution, right? So the idea is I am this MAC address that translates to some IP address, right? So if you guys are looking for sending this out to your gateway server so you can get out to the internet, it looks for your 192.168.1.1 or whatever your firewall is, right? Well, when it does the lookup at the switch and says who's 1.1, here's the MAC address, I ship all my traffic that direction. ARP poisoning says this is not 1.1, I'm 1.1, send all your traffic to me. All right, we're poisoning the ARP table inside the switch, or the client in this case. A lot of times we'll actually poison the client and tell the client, hey, we are the router, ship that stuff to me. In which case we take it, we log it, and then we ship it off to the actual internet. That allows us to be in the middle, seeing all the traffic that's transpiring across the network, right? And you guys will do those type of attacks in grad school, or you should have already done them if you are in grad school. It's really fun to do in a hotel. I'm just kidding. This is being recorded. All right. Anybody got any questions over this material? And when I say in a hotel, it's my hotel. I own the hotel. No rights. Copyright reserved.
Of course.
All right. First, stop that recording.